ladies, this is lesson 5.9, and in this lesson we're going to write polynomial functions and models. So I have just a few steps up here listed from 1 to 6 that you're going to follow, and then just a few questions that you're going to ask yourself every time you look at one of these graphs. So first, you're going to find the zeros. So the first step of writing a polynomial function is knowing what the zeros are, because once you know what the zeros are, you can find the factors. So let's look at our graph, and let's find the zeros. So here's a 0, here's a 0, and here's a 0. There are 3 real zeros. They are -2, -1, and +2. So those are our zeros. Next, we can write the factors. So if -2 is a 0, x plus 2 is a factor, x plus 1 is a factor, and x minus 2 is a factor. All right, and then next we can write the function in factored form. So in factored form, f of x equals, now we might have a leading coefficient that's something other than 1. So far we've been working with leading coefficients of 1, but we're going to write it in factored form assuming that there is some other leading coefficient. So it's a times a factor, x plus 2, times another factor, x plus 1, times a third factor, x minus 2. All right, let's look at this. Let's look at this polynomial function, and we'll look at our graph too. So first of all, how many zeros do we have? We have 3 zeros. How many turning points do we have? Here's 1, and here's another. 2 turning points. What's the degree of this polynomial function? There's 1x, 2x, 3x, so it's going to be cubic. So we have a degree of 3. And now what's the leading coefficient? Is it positive or negative? Our degree is odd. Well, let's look at our graph. Here's the end behavior of our graph. So that's another thing, it tells us our degree is odd. But the leading coefficient, is that going to be positive or negative? Well, our end behavior resembles a line with a positive slope. So our leading coefficient, we don't know what it is, but we know it's going to be positive based on the end behavior of our graph. All right, so we found our zeros. We wrote the factors, we wrote our function in factored form. Now we need to find another point on our graph. So here's another point that's not a 0. When x equals 0, y equals -8. So let's use that, like we did with the quadratic functions, let's use that to solve for a. So we know when y is -8, that equals some constant, a, times 0 plus 2 times 0 plus 1 times 0 minus 2. So now our goal is to find our constant, find our leading coefficient. And we're going to do that by substituting our x and our y value in. So now what we have to do is just simplify. So -8 equals a times 2 times 1 times -2, which is -4a. Then we can divide both sides by -4, and we get a equals 2. All right, so now, find another point, yeah, we did that. Substitute x and y values of the point to solve for a. We did that, a is -2, and now we can write the polynomial function. F of x equals a times our factors. So f of x equals 2 times our factors of x plus 2, x plus 1, and x minus 2. So what we already knew was that our leading coefficient was positive, that it was degree of 3, which we have 3, degree of 3, and we have 3 zeros, it's degree of 3, so we have 3 zeros, and we have 2 turning points. That's 3 minus 1. All right, let's look at one on your own. So for this one, I want you to pause the video while you work, and then you can unpause for the solutions. So follow those 6 steps, find your zeros, write the factors, write it in factored form, find another point, and substitute that point for x and y so you can solve for a. Then write your polynomial function. All right, our first step is to identify what we know. So how many zeros do we have? Well, we can see on here 3 zeros. 1, 2, 3. How many turning points? Here's 1 turning point. Here's another turning point. That's 2 turning points. The degree is odd. So if we look at our end behavior of our graph, we can see that it changes. So as x approaches negative infinity, y approaches positive infinity. And the opposite is true for positive infinity for x. Y approaches negative infinity. So we know it's an odd degree. And then lastly, the leading coefficient. We know that's negative because the end behavior resembles a line with a negative slope. So next we want to identify our zeros and our factors. So our zeros, -3, +1, and +4. So our factors are x plus 3, x minus 1, and x minus 4. After that, we want to write our function in factored form. So f of x equals a times x plus 3 times x minus 1 times x minus 4. And we found another point on our graph, -0, -4. And we substituted those values in for our x and y. So we got -4 equals 12a. Divide both sides by 12 and we get a is -1/3. We already knew that our leading coefficient was negative, and this verifies that. Once we actually have it written out as a polynomial function, you want to make sure that everything you already knew is true about your function. So f of x equals -1/3 times x plus 3 times x minus 1 times x minus 4. All right, now let's look at one where it does not give you a graph. We might want to sketch this out. Okay, now you can graph it on, well, actually you can't graph it on your calculator because you don't have the function yet. But you can sketch out a graph of this. So let's just see what this would look like. So here's our coordinate plane. We know it passes through -3, -1, 10. So somewhere up here, 0, 0, and 4, 0. So if it passes through these points, here's what our graph will look like. Probably something like this. Now, it's not going to be perfect, but it's going to be pretty close to that. So how many zeros do we have? Here's a 0, here's a 0, here's a 0. We have 3 zeros. How many turning points do we have? 1, 2. What's the degree? Well, this resembles polynomial end behavior. Oops. Actually, this is the end behavior. So it resembles a line. The end behavior resembles a line with a positive slope. So the degree is odd, and the leading coefficient is positive. So that's what we already know. Now let's actually list our zeros. -3, 0, and 4. Once we have our zeros, we can list our factors. X plus 3, x minus 0, which is just x, and then x minus 4. So now let's write this in vector form. So f of x equals a, which we don't know yet, times x plus 3, times x minus 4. So now we need to pick another point. Here's our other point, -1, 10. So when y is 10, x is -1. So -1 plus 3 times -1 times -1 minus 4. Right, now let's simplify this. So 10 equals, we still don't know what our a is, that's what we're solving for. -1 plus 3 is +2 times -1 times -5. So that is 10a. And then in order to solve for a, we'll divide both sides by 10. And we get a equals 1. So now we can actually write our polynomial function. We know that our leading coefficient is positive. Here's our leading coefficient, a. It's positive. So now we can write our polynomial function. F of x equals 1. We don't need to write that. Times x plus 3 times x minus 4. We don't need to write 1 because it's multiplication, and if you multiply anything by 1, you have its sum. That's the multiplicative identity, so we don't actually need to write that, it's implied. Alright, so please jot down any questions that you have, and we can go over them in class or one-on-one next time I see you. So feel free to pause or rewind or fast forward. And catch up on anything that you may have missed in the video.